Hello everyone, welcome back to my series of turning an alternator into a brushless DC motor. So in this video we're going to get down to modifications to the alternator itself. Now as you can see here I have two alternators. Now any alternator will work. I would say as long as I wouldn't look at some of the big large alternators for like 24 volt charging systems, but car alternators, truck alternators, they'll work great. This one here was off of a little Toyota car, and this was off of a little truck that I had given to me. Alright, so what do you have to do to the alternator itself? Some of this I'm not going to get super in depth with because it will depend on your alternator, but it should basically be pretty much the same. And some of it you may have to use some imagination with. Alright, well, let's get into it. What do you have to do? Well, the first thing you have to do is the back of the alternator, strip everything off of it. There'll be a set of diodes on it, and the regulator, and in the middle here, there is a set of brushes. Now, them set of brushes should come off on their own. So what you want to do is strip everything off down to your individual wire connections. Now, you'll have 4 of them on your alternator. Doesn't matter which one it is. This one here happened to have these little ring terminals on the ends. And this alternator has just wires. So, once you have it stripped down to this point, have your alternator stripped down to this point, and a question I get all the time is, how do I identify what connection is what? Well, this is easy. So, I have this alternator right here, pretty much already all tore down. Now when you pull the backs off of these, be very careful. That way you don't break it. A lot of times the bearing can be corroded up in it, or the shaft corroded up in the bearing, something like that. So now I have it stripped down. Now some alternators you don't have to do this. You don't have to pull your backside off, but it's a handy thing to do anyways, to identify your wiring connections. So I have 4 wires sticking up on this one. Now, try and get up here nice and close and see. You notice this one here, this connection right here, has 3 wires all running into one connection. And the rest of them are just one wire. Hopefully I can get a good view there of that. Yeah. Okay. Now like I said, all alternators are going to be like this. So this connection right here is called your center tap. Now, let me get a piece of paper here to demonstrate this. Now, if I remember right, I demonstrated this in my previous video that I had made. But that wire with all 3 connections to it, it's our center tap. This is that one wire, this black dot, and all 3. Well, all 3 of these are going to have a coil coming off of it. Now, these coils, that's all these windings around in here. That's your coils. Now we're just demonstrating this by showing one, but there's actually several coils wound up in there. So then, now into the coils, here, here, and here, that's where we connect our ESC, our speed controller. So basically what this is, it is a 3-phase motor. 3-phase motors are very common. They're used in industrial stuff. They're super common in radio control, cars, trucks, airplanes nowadays for hobby use. And I have one here. We'll compare them also. So anyways, these three connections are the ones you want. You do not want to mess with the connection that has all three wires running together. You want to isolate that one off by itself and forget about it. So your speed controller will hook up to the other three, not that one. So to kind of compare this, I have here this is a radio control airplane motor. Now, what you see here has three connections coming in here, and somewhere in all this mess of coils, you have the connection where all three of these come together. So you see all the coils here. Now the difference in this motor and our alternator is this RC motor is called a outrunner. That means the inside of the motor stays stationary and the outside spins. And that spins your shaft. That is a outrunner motor. Now, one that the outside stays stationary and the inside spins, that's what in the RC world is called a in-runner. So outrunner, the outside spins, in-runner, the inside spins. Now another thing we have is when you tore your alternator apart, remember them brushes that was on the back side of it, two little spring-loaded deals that made a connection to this back of the shaft here on these copper connections? Well, those brushes are for the field coil. Now, when you put 12 volts to that field coil, you're basically making a large electromagnet out of the rotor. Now, this here rotor, I would have to pull this pulley and that nut off of it to pull it out to show you, but it's also got a whole bunch of wiring wound on it. So that creates a large electromagnet in it. Now, back to the RC motor. This is a permanent magnet motor. As you can see, all these here, these are magnets that are glued in. So as your speed controller energizes these coils in a certain order, the same way it will do on the alternator, it creates a magnetic field that attracts these magnets, making the motor spin. Well, that's what we're doing here, is we're putting power to the field coil, which is on the rotor in here, and that's magnetizing it, and then as the speed controller, in its certain order, it's energizing these coils, and it will make it spin. So, now, other modifications we will have to do. Let's go back to my motor here that I already have running. Now, you will need somehow or another to mount your brushes to your shaft, to where they make connection to it. That's where I say you're going to have to get creative on that part. I made for this motor, this is a 3D printed part that I made for it that holds the brushes in there, and I have my two wiring connections to the brushes. You can take the brushes and possibly epoxy them to the housing of the motor somehow or another. Anything, 3D print something. My earlier video that I made, you will notice I had part of the diodes and stuff on the back of the motor that these brushes connect to. So those mounted to that, the part of the diodes. Now you can do that, but you just leave the diodes and everything. They have to stay disconnected. So you can use that to mount this. Just get creative. See what you can come up with, as long as they make a really good connection and they allow the motor to spin nice and free. So there's where you're going to have to get creative. Now, another thing you do is with the speed controller has what's called bullet connectors on it. Now these bullet connectors, these nice little gold-plated connectors, they're very, very common nowadays in the RC world. This is the male connection, you'll need to make you some wires. And if you're going to go that route with the bullet connectors, you have to make you some wires and solder them onto it. You could use the crimp connectors even if you wanted to permanently mount this to your ESC, connect your wires to it. They're good enough for NASA's space shuttle. They do use those, believe it or not. They're good enough for them. They're good enough for me, and I've never had any problems with them. So you could use the crimp-on connectors even to make your wiring connections. And then once you get your alternator all together, got your brushes on it, they're making good connection, everything like that, then we're going to test the alternator. Now, honestly, you should probably do this before you do all that work to make sure your alternator does not have a problem. Now I have here a multimeter here, and I have it set in the ohms. So I'm going to go through and I'm going to check my connections. Now remember that center tap, I'm going to go to it. Good. I'm going to make note of the ohms. Good. Good. Those all come out the same. So I know that these coils are perfectly fine. I am also going to test each connection on my rotor, my field coil. Now this here, make note of it. Write it down. This one here is 2.9 ohms. So I'm going to make a note of that here. 2.9 ohms. Now we're going to use that to figure out how many amps our field coil is going to draw. So now that we have all the connections, you can go through and check them in a combination here just to make sure everything's good. We're going to take and go off of them, and I'm going to check to the body of the alternator. Make sure nothing's shorted out inside of it to the body, the coils to the body of the alternator. And this one here is good. My other alternator that I've been running, it also tests out really good. Alright, so that's what you need to do to modify your alternator and to check it to make sure it's going to be in good order to run. Now once you have everything, your brushes, everything all done, then it's time to move along to the next video. Well, in the next video we're going to get down to building the circuitry, the breadboard with the Arduino. We're going to get down to doing that, how to hook all that up to the alternator. That way you have that to control the speed controller and also to control the power to the field coil. So until next time, thanks for watching. Hope you enjoy this videos. Hope you're getting something out of them and can put it to some kind of use. I would be very curious to see whatever you end up with doing with this. So thanks for watching, and until next time, see ya.
απείρακτος. Δεν έχω πειράξει την περιέλιξη, έχω αλλάξει μόνο το παινίο του ρότορα με μόνιμο μαγνήτη. Εκτός από ανεμογεννήτρια, μπορείτε να φτιάξετε και μοτέρ. Άμα ψάξετε λίγο, άμα κάνετε μία έρευνα στο ίντερνετ, είναι πάρα πολύ. Κατά κύριο λόγο στις Φιλιππίνες έχω δει πάρα πολλές τέτοιες μετατροπές, οι οποίοι φτιάχνουν καρτ και μοτοποδήλατα, ηλεκτρικά μοτοποδήλατα, με τη χρήση δυναμό αυτοκινήτου, και τους βγαίνει σχεδόν τζάμπα. Δηλαδή μόνο για τις μπαταρίες πληρώνουν και για το κύκλωμα οδήγησης. Τώρα εγώ έχω συνδέσει εδώ ένα πολύ απλό κύκλωμα. Ένα πάρα πολύ απλό κύκλωμα, το οποίο κάνει το δυναμό να λειτουργεί σαν μοτέρ. Και είναι αρκετά γερό. Βέβαια πιο γερό είναι με ένα άλλο κύκλωμα που έχω φτιάξει με sensors. Αυτό είναι sensorless, είναι χωρίς sensors. Άμα αυτόν το δυναμό θα τον ανοίξω, να δείτε ότι μέσα δεν έχει τίποτα. Τα έχω πετάξει όλα και έχω κρατήσει μόνο το τύλιγμα το αρχικό και έχω αλλάξει το παινίο του ρότορα με μόνιμο μαγνήτη. Οπότε μια εφαρμογή ακόμα που μπορούμε να έχουμε είναι και αυτή. Πολλοί φίλοι έχουν κάνει τη μετατροπή αυτή μόνο για χρήση για ανεμογεννήτρια. Για να δούμε τι αποτέλεσμα έχει. Θα αφαιρέσουμε το κυκλωματάκι. Είδατε ότι δουλεύει, δεν χρειάζεται να το λιβανίζουμε άλλο. Το πετάμε στην άκρη. Και εδώ θα χρησιμοποιήσουμε θα χρησιμοποιήσουμε τις δύο από τις τρεις φάσεις. Θα βάλουμε τη 12V τη λάμπα. Το μειονέκτημα που έχει όταν αλλάξουμε μόνο το μαγνήτη, αλλά δεν αλλάξουμε το τύλιγμα, είναι ότι στη χρήση για νεμογεννήτρια χρειάζεται περισσότερες στροφές, αλλά έχει και ένα πλεονέκτημα, ότι μπορεί να αποδώσει τα αρχικά αμπέρ. Αυτός εδώ λέει 70 αμπέρ. Αν μπορούμε να του μεταφέρουμε κίνηση τέτοια ώστε να αποδώσει τα 14V που λέει εδώ πέρα, θα μπορεί να φορτίζει με 70 αμπέρ. Οπότε έχουμε και ένα συν, αλλά οι αυξημένες στροφές εξακολουθούν να είναι ένα μείον. Τώρα μην ακούτε που παίρνει λίγες στροφές το μοτέρ, το έχω στο γρήγορο, το γυρίσω στο αργό. Για να βγάλει 12V,